Alright, so starting on the next page, we have to do two things. We need to set up or identify the geometric relationship first, and then we need to set up and solve an equation that represents that. So on this first one, we're just looking at angle 4 and angle 5. So that would be, here's angle 5, and then here is 4. So the first thing you might notice is that we have a little square arc right here. So this would show that angle 1 is a 90-degree angle. You might also notice that you have a straight line here, which means that this entire angle 1, 5, and 4 combined would be 180. So that means that angle 5 and 4 must combine to equal 90, so that these two plus this one equal that 180. So angle 5 and 4 should combine to equal 90 degrees. So the special name for when two angles add together to equal 90 degrees is complementary angles. So you can just write complementary here. Alright, now the equation, we basically just said it, so we're taking angle 5, adding it to angle 4 to equal 90. So that's just what we're going to write down. So we have angle 4 plus angle 5 equals 90 degrees. Okay, for the second one, so this one we're looking at angle 2 and 4. So we have angle 2 here, and then we have angle 4 here. First thing I notice about these is that they are opposite from each other. So the special relationship name for that would be vertical angles. The most important thing we should know about vertical angles is that they're always congruent. So angle 2 is going to be congruent to angle 4. So when you're writing an equation, you should know that if you have two congruent angles, the equation will be set up equal to each other. So you'll just have angle 2 is equal to angle 4. The next one, we're looking at angle 2 and angle 3. Angle 2 and angle 3. Important thing to notice here would be that these two angles are combining to create a straight line. So if I took this angle, angle 2, combine it with angle 3, you're going to have a straight line. Something that you should automatically be thinking when you think of straight angles would be that they equal 180 degrees. Which means that when I combine angle 2 and angle 3, I should get 180. So the special relationship for that, it can fall under two names. So we have a linear pair and supplementary angles. So they're a linear pair because they're a pair of angles that form a straight line. They're supplementary because they add to 180. So the equation is just that. So I have angle 2 plus angle 3 equals 180. Alright. Now for this next part, we need to do a couple things. Let's see. So in the first part, we're going to identify the geometric relationship. Then we need to set up and solve an equation. And then we're going to use the value that we get from solving that equation to find the missing pieces. So missing angles and missing segment lengths. So let's look at this first one. So we have a segment. So we know we're dealing with relationships that have to do with segments. The first thing I would look at is any special marks that you have. So on this one I see these tick marks. That means that we have some congruency here. So that means that segment PN should be congruent to segment in R. So I'm going to write that down on the side just so you can see that. So segment PN will be congruent to segment in which means that their distances should be equal. So PM should be equal to MR. Now I can use that information to set up my equation. So first we will go ahead and identify the relationship. So when I have a segment that is split into two equal parts, that means that this N is doing something special here. N is our midpoint here. Something that we should think about when we have midpoints is that we have bisector. So in this relationship would be considered a segment bisector. That would be the first part of the question. Okay, now going back to what I was talking about with the equation, we know that these PM and MR, those two segments should be equal to each other. So when we set up an equation, we should represent that. So the distance for PM is represented by 4x minus 12. I'm not sure what that says. I think it is plus, I think I'll just put minus there. So we have 4x minus 12. And then plus negative 2x plus 21. I added things, so I'm not going to do this. I think this, this little thing confused me here. So I don't think this showed up on your paper. So I know some of you might have put like 4x plus 12. That's fine. It ultimately just comes down to the solving part of it. So I'm going to write 4x minus 12 because I think I can see a little subtraction symbol. So this should be equal to this. So I have 4x minus 12 equals negative 2x plus 21. So now that is fine for part 2. The third part would be that we need to solve the equation, use the variable to find the missing segment lengths here. So when we go ahead and solve, we're going to add 12 to both sides. So you should get these cancel out. I have 4x equals 2x plus 33. I'm going to add 2x to both sides. So 6x equals 33. And then 33 divided by 6 comes out to about 5.5. If you put 4x plus 12 in your equation, you're going to get a different value for x. That's fine. So x then should equal about 5.5. So the way that you can check this would be doing part 3. So part 3 says to use the variable value to find the missing angle or segment lengths. So right here we're trying to find segment lengths. So what I would want to do is plug in 5.5 for our x values. So I'm going to take, find a good place to put this here. So I should have 4 times 5.5 minus 12. This comes out to be 10. And so what I should automatically be thinking is that if I said that 4x minus 12 was equal to negative 2x plus 21, that this side should also be 10 in R. So let's go ahead and plug in. Let's see what we get. So negative 2 times 5.5 plus 21. So that should come out to, so that also comes out to 10. Which means that the value 5.5 works for x. So this was the value we got for Pn, and this was the value we got for M. Okay. So, like I said earlier, if you put like a plus sign here, Your values might look a little bit different, but the way to check that would be just plugging it back in, making sure that PM is equal to N1. Alright, move on to the next one. So the next one over here says ray KN bisects angle JKL. So we're talking about ray KN bisects angle JKL, which means that we have congruent angles here. So anytime you have a bisector, it's splitting your angle or segment into two equal parts. So this relationship name would be an angle bisector. Okay. For the second part, we just need to set up an equation. We basically already explained it, so we know that the bisector splits the angle into two equal parts. So the two equal parts would be this angle and this angle. So you just copy the expressions into your equation. So the angle measure for JKN was x plus 31. And we said that would be equal to the angle measure for MKL, which was 3x minus 9. And now we just need to solve. So we're going to bring 9 over to the left side. Should get x plus 40 equals 3x. Move the x over. And then x equals 20. So x equals 20. Now the third part of this would be to plug it back into our angles and find out what the angle measures are. So kind of like on the last one, something we should be thinking about is if x equals 20 and I know that the ray KM bisects it, then these two angles should be congruent. So angle JKM should be congruent to angle MKL, which means that whatever I get for JKN should be equal to MKL. So let's go ahead and solve. So if x equals 20, that means that JKN will equal 51 degrees, and then angle MKL should equal 51 degrees. So I'll show my work here. So 20 plus 31 is how I got that one, and then we're just plugging in x here. So that was 3 times 20 minus 9, which was 51 degrees. We are given that the distance ST equals 6x plus x, and then the distance from T to U equals 4x plus 18. So if it helps you to kind of draw out what that looks like, you can do that. So I have 6x plus 6 was ST, and then TU would be 4x plus 18. So, seeing that these two parts that have their measures, we need to look at the diagram and see if there's any special markings that might tell us something about the relationship. So something you might notice here is our tick marks. If you remember what our tick marks mean, that means that we have two congruent segments, which means that ST would be congruent to TU. So that means that when we're setting up our equation, that the distance from ST should be equal to the distance from TU. So let's go ahead and write down our name. So this is also kind of like the last thing we saw. We have our T in the middle bisecting our segment. So our relationship name would be a segment bisector. second part, I'm going to set up our equation. We know that ST should be equal to TU, so we'll go ahead and copy that down with our expressions that we have. So 6x plus 6 is equal to 4x plus 18. Now, solving that, bring the 6 over to the other side. So you should have 6x equals 4x. So that's 12. Move the 4x over. We have 2x equals 12. So x equals 6. Alright, now we're not done. We know x equals 6, but we need to plug it back into our equations and see what we get. So for the value of st, we have, this would be 3, st equals 6x plus 6. So we're gonna substitute in our x value, which was 6. And so 36 plus 6 is 42. So if we know that this is 42, when we're solving, we should want this to also be 42, this from T to U. So let's go ahead and see. We have TU equals 4x plus 18. So we're plugging in 6. So we get 24 plus 18, which equals 42, which means that we are good. I'll go ahead and do this bottom one since we're talking about segment bisectors. So this one, just like the one that we did before, we see a T in the middle, we see our tick marks, we know that they should be, we know that Q, T would be congruent to TR, which means that our distances are going to be equal. So again, we have a segment bisector. And now, when we're going to set up our equation, we said that QT equals TR, so we're just going to plug in the values that we have. So 4x minus 10 should be equal to 17. Yeah, 17. Now we're just going to solve. So 4x equals 88. We're going to divide by 4 on both sides. So x equals 2. So once we found our x, we need to plug it in and see what we get for values of QT and TR. So QT was 4x minus 10. So now when we're plugging in our x, we should have 4 times 22 minus 10. So that should give you 78. So if we know that this piece up here is 78, we should also want this piece to be 78, which I've already gave that to us, so we know that we are correct. Alright. So going back up here, these examples are the same as the ones that we have just done. So on this one, it says BD bisects ABC. I think it should say DB bisects angle ADC. So we're talking about this ray, DB bisects ADC, which means that these two angles should be congruent. So again, we have an angle bisector. So when we set up our equation, we should automatically be thinking, well, I have an angle bisector, which means that my angle ADB should be congruent to angle BDC. And since they're congruent, I know that I can set up the equation to be equal. So for the value of ADB was 11x minus 7 know I'm setting it up equal because the angles are congruent, and then the angle measure for BDC was 5x minus 3. So now I just need to solve. So I can bring my 7 over. So that 11x equals 5x plus 4. Bring my 5x over. Divide by 6 on both sides. So x equals 4 over 6, which if you want to write as a decimal would be about like 0.6 repeating. So I'm just going to leave it as 4 over 6. Now we need to plug it back in to find our values. So I'm going to come over here, number 3. So angle ADB should look like 11x minus 7. So we're going to plug in the value we got for x, which was 4 over 6. So 11 times 4 over 6 minus 7 should give us about 1/3 or 0.3 repeating. So if I've done this right, I want ADB to equal the same as BDC. So when I'm plugging in 4 over 6 to my next equation, I should get 1/3. So this was the value for ADB. Now I want to do my next one, which was 5x minus 3. So when I'm plugging that in, I should get 5 times 4 over 6 minus 3, which should give us, let's see, 5 times 4 over 6 minus 3, which was also 1/3. Alright, so that checks out so that I know we have 2 equal angles. So our algebra is good there. Alright, now for the last one. Says ray BD, which would be this piece here, bisects angle ABC, which is this entire angle. So the word bisects means that we're splitting it into 2 equal angles. So we can put some congruency marks here. So I know we have an angle bisector. Which means that for our equation, we should know that angle ABD is congruent to angle DDC, which means that when we're setting up our equation, they should be equal. So I have 10x minus 51 equal to 6x minus 11. So that should be your equation for this one. Now, I just need to do some solving. So I can bring 51 over the other side. So I should get 40 over here. So 10x equals 6x plus 40. Move the 6x over. Divide by 4 on both sides, so x should equal 10. Now I need to do my third step, which would be plugging it back in to find the missing values. So for the first one, we have angle ABD, which equals 10x minus 51. Now I need to substitute in 10. So I should have 10 times 10 minus 51. That will give us 49 degrees. So this is over here is going to be 49 degrees. And then if we've done our algebra right, we should find that DDC also equals 49 degrees. So let's check it out. Angle DDC equals 6x minus 11. So let's do 6 times 10 minus 11. So 60 minus 11 equals 49 degrees. So that checks out. So we know we've done our algebra right. So both of these angles here are 49 degrees. So if you've noticed here, this is going to be set up the same as your test, so make sure that you're doing all three parts. So the first part that we did was we found the name of the relationship. That was the first part. The second part was that we set up an equation. I've done that in blue. After you set up an equation and solve, you need to take that value and plug it back in to find the missing values. And that would be the third part that we've done in here.